Gravitas Recommendation Engine Protocol, GREP, Blockchain Load Balancing. Introduction. As blockchain systems grow in complexity, achieving optimal resource allocation and balancing becomes an increasingly challenging task. Traditional load balancing methods struggle to adapt to the real-time demands of decentralized networks, where nodes vary widely in capabilities, workloads, and reliability. Enter the Gravitas Recommendation Engine Protocol, GREP, a physics-inspired framework designed to provide adaptive and transparent recommendation balancing for blockchain systems. This article explores how GREP leverages gravitational averaging to dynamically allocate resources, balance workloads, and optimize the performance of blockchain validators. Using blockchain-specific attributes, GREP creates visually stunning and highly effective simulations that demonstrate its potential to revolutionize resource distribution in decentralized systems. What is GREP? At its core, GREP is a real-time simulation engine that applies principles of gravitational physics to decision-making and resource allocation. Instead of relying on static rules or predefined thresholds, GREP uses primary mass nodes, PMNs, and dynamic nodes, DNS, to create a self-balancing system. PMNs represent key components of a blockchain network, such as validators or nodes, each with specific strengths and preferences. DNS represent workloads or transactions, dynamically attracted to PMNs based on their attributes and gravitational forces. This interaction generates emergent behaviors that mimic natural systems, resulting in optimized and adaptive resource distribution. How GREP applies to blockchain systems. Attributes for blockchain balancing. In a blockchain system, each PMN validator is defined by a set of attributes that represent its capabilities and preferences. Transaction load, the volume of transactions the node can handle. Node reliability, a measure of the node's uptime and consistency. Latency, the time taken for the node to process and propagate transactions. Hash power, the computational power available for cryptographic tasks. Network contribution, the validator's role in maintaining the blockchain network. Propagation efficiency, the speed and accuracy of block propagation. DNS workloads or transactions also carry these attributes, enabling GREP to match them dynamically with the most suitable PMNs. Weighted gravitational preferences. Each PMN assigns a unique weight to the attributes it prioritizes. For example, one validator might prioritize transaction load, while another focuses on node reliability. These weights influence the gravitational forces between PMNs and DNS, guiding workloads toward the most compatible validators. The blockchain simulation, how GREP works. In our blockchain-inspired GREP simulation, we model validators as PMNs. Each validator is assigned preferences and positioned within a virtual environment to represent its unique role in the blockchain. Transactions as DNS, transactions are dynamically generated with attributes reflecting their requirements, e.g., load, latency, hash power. Gravitational interaction, DNS are pulled toward PMNs based on the weighted gravitational charge calculated from their attributes and the validator's preferences. Equilibrium and optimization. Over time, DNS find their optimal PMNs, creating a balanced and efficient distribution of workloads. This system not only provides visual clarity, but also ensures that workloads are allocated in a way that maximizes efficiency and minimizes bottlenecks. Key results from the blockchain simulation. Realistic motion, transactions move dynamically, influenced by the gravitational pull of validators, mimicking real-time decision-making. Deterministic allocation, DNS cluster around PMNs that match their attributes, demonstrating GREP's ability to balance workloads adaptively. Transparent metrics, gravitational charges, and node capacities are displayed in real time, providing full transparency into the decision-making process. Advantages of GREP for blockchain systems. Adaptive balancing. GREP responds dynamically to changes in node performance, workload distribution, and network conditions. Transparent decision-making. Every interaction is explainable through gravitational formulas, offering unparalleled clarity. Scalability. GREP scales seamlessly with increasing nodes and workloads, maintaining efficiency without requiring exponential computational resources. Customizability. Validators can define their own preferences, enabling tailored balancing strategies for diverse blockchain ecosystems. Visual insights. GREP's stunning simulations provide intuitive visualizations of complex systems, making it easier to identify and resolve bottlenecks. Real-world applications. 1. Load balancing for validators. GREP ensures that blockchain workloads are evenly distributed across validators, preventing overloading and improving overall network performance. 2. Optimized resource allocation. By dynamically matching workloads to validators based on real-time attributes, GREP maximizes resource utilization and minimizes latency. 3. Network performance analysis. GREP simulations provide valuable insights into how transactions flow through the network, enabling developers to optimize configurations and improve scalability. 4. Blockchain governance. In decentralized governance systems, GREP can simulate voting dynamics, ensuring fair and transparent allocation of influence. The future of GREP in blockchain. GREP represents a paradigm shift in how blockchain systems approach resource allocation and balancing. By harnessing the principles of gravitational physics, GREP offers a transparent, adaptive, and scalable solution to one of the most pressing challenges in decentralized networks. As blockchain ecosystems continue to grow, GREP's ability to dynamically balance workloads and optimize performance will become increasingly valuable. Whether integrated into existing protocols or deployed as a standalone service, GREP has the potential to transform the way we think about blockchain optimization. Gravitas Recommendation Engine Protocol, GREP, balancing the future of blockchain, one transaction at a time.